All right, welcome back everybody to the Additive Snack podcast. I'm your host, Fabian Feld, and today I am super pumped to bring this conversation back to the energy sector. We've had multiple guests on the show talking about the industry of energy generation, mainly also when it comes to gas turbines. But today we're diving into a topic we haven't really covered on this podcast, which is really the oil and gas industry and how additive manufacturing is helping to shape that sector today and also in the future. And therefore, we have a really awesome guest with us, and that is Christopher Beeson from ExxonMobil. Christopher, or Chris, has been on the forefront of additive in the oil and gas space for quite some time now, and has really also been an instrumental individual to push additive forward in the oil and gas sector. So therefore, today we'll touch on a bunch of different topics. We will touch on the journey Exxon took in order to integrate additive into their operations. We'll talk about their center of excellence, different partnerships with universities, but we'll also, of course, talk about different applications and different additive manufacturing technologies that are shaping the oil and gas sector today. So therefore, without any further ado, Chris, welcome to Additive Snack.
Thank you, Fabian.
So, Chris, before we dive into Exxon and before we dive into the depth of additive in the oil and gas sector, let's talk a bit about your journey. How did you get into oil and gas? And then specifically, when were you first introduced to additive manufacturing?
Well, I tell some people jokingly that I've been an additive for 31 years, and they start calculating in their head, 31, that's not. So jokingly, I began welding when I was 15 years old, so it's not subtractive, it's additive. So just not with a robot, right? So additive manufacturing was never in the forefront at all back then, but I began welding. And I took machine shop technology in college, and I knew I did not want to be a machinist after that. I did not want to stand in front of the same machine every day making similar parts. That would have drove me crazy. So during my welding journey, jumping here and there, I ran into a GE crew that I did some welding for, and they asked me to step in after the welding was finished and help them with some gas turbine work. So I said, I have nothing else to do, so let's do it. And spent 16 years with GE in the GE power and water world. So we were oil and gas and power and water together until 2007, 2008 time frame. And then they let everyone choose when they split, where they wanted to go. And I stuck with power and water. Ended up at the Baton Rouge refinery doing some major gas turbine overhauls as supervision. And they hired me to manage the rotating equipment maintenance crews here for all their major machinery. So compressors, gas turbines, steam turbines, gearboxes, big induction motors. In 2019, I kind of was seeking some new technology and stumbled on to 3D scanning. And I knew how 3D scanning could help us relocate equipment in the fields, such as removing machinery, but scanning that shaft center line before that machinery left. And then if a new machine was put in, we could do that more seamlessly and sooner, right? So if it makes sense, if a compressor is the machine to get replaced and it's connected to a steam turbine driver, but the driver had to go to an outside shop and then it came back earlier, I would be able, as soon as that steam turbine came back, to locate the new compressor shaft center line to shaft center line. So that was primary reason for buying it. In 2021, everybody knows API 20S was born. In our business, we did not really do anything as planned for additive manufacturing before 20S. We do have some parts that were put in service prior to that based off of need to save lots of capital because a part was obsolete. So we did those things outside of any standard, right? Just because they had to be done. Mm-hmm. But in 2021, there was a push and a driver now that 20S was born that, go and do, right? So they identified site champions for each site So because I had the scanning technology already, those two go hand in hand when you need to produce something. So half of what we do is scanning a damaged or just a part, maybe in our store stock or one that's a part that's been disassembled in the machine shop. So that workflow works together, and kind of the rest is history. I worked with our campus additive manufacturing leads, and recently our MTech, which is our ExxonMobil Technology Engineering Group at our Houston headquarters, they're kind of the push is they're supposed to find new technologies, implement them, and push them down the sites. Once that technology is mature, then they get rid of that group at our headquarters and just tell the sites, okay, it's mature now, go and do. So that recently happened. So corporate headquarters has no additive there. Now it's pushed down the sites to go and do. So I'm, in addition to the special purpose machinery execution supervisor, which means I take people to the field to overhaul this major machinery. I'm the additive manufacturing lead for the Baton Rouge area. So we have a plastics plant, a polyolefins plant, a chemical plant, a lubes plant, refinery, obviously, some midstream and upstream activities, which don't do a whole lot right now. Most of our stuff in that area is contracted. But I guess above that, since I'm more active than the rest of the North American sites, I lead the North American Additive Manufacturing Roundtable, where we mentor all of our other sites on what technology to use to make a part, what vendor to go to make the part, give them any kind of assistance they need to scale additive across North America. But now that initiative at headquarters is gone, I'll be leading the roundtable for the globe instead of just North America. So our Singapore site does more than any other site. And
Interesting.
As we all know, most of those machines are manufactured in Europe or Asia, the ones we use every day. So it makes perfect sense that they started before we did and scaled faster than we did, because they have more machines available to them, and some very close to their facility. And I think we may have a surplus of casting facilities versus what's available to them over there. So it's kind of the difference in the globe. But scaling additive is my job, and amongst other university things we'll talk about here shortly. But yeah, that's kind of where I'm at.
Yeah. Fun job.
Yeah.
Fun job for sure. Seems like you guys are the only ones with a surplus of casting capability.
There's lots of casting facilities here, in the US.
It seems like everyone else in the US is struggling to get cast components on board. But that's a different story, maybe. I'm really interested in the strategic approach of Exxon. Right? I think we see various different organizations trying to implement additive manufacturing with different models. Some start very distributed, some start more centralized. You guys started as additive as a corporate strategy, and then, as you just mentioned, you distributed it now to individual sites. Can you talk a little bit more about how that initial core started at Exxon in the corporate space, and is that how Exxon typically approaches new technologies, or was that unique to additive?
Yeah, so we actually have a 3D printing lab in the basement of our headquarters in Houston. We have another lab in Clinton, New Jersey. But these two labs, they were born for non-metals purposes. They were doing various things, but one of those things is actually printing the oil cans that you buy at the auto parts store. Like, they were doing various things. So whenever the corporation realized, hey, laser powder bed fusion is now surpassing the density of a casting, I think headquarters said, we better get somebody, going on additive and get them involved. That way we're not behind the curve once we realize we need to pull the trigger and start printing parts. And we have a standard to go by, API 20S. So they did that. So they pulled John Barnes, one of my colleagues, out of the basement and the lab, and they made him our 3D print advisor. And he was our person to go to. was our 100% go-to person. He went to every conference, every expo he could, visited vendor shops, and learned as much as he could. And then whenever they created the site champions for each site, we all kind of took his lead and traveled with him and started doing the same thing. So he and I got really close and traveled a lot with each other and went to all these places together. And it's kind of the rest is history. But our digital supply network is really the driver for all of this. So when I say digital supply network, I mean how we're going to add parts to a cloud or 3D models. So the value capture for us is monumental for getting parts out of stores off of the shelves. So if you think about how many billions of dollars Exxon may be paying every year for every site across the globe in inventory tax, reducing that inventory tax is quite substantial. So, for example, we may have an operating unit that has, this pump that if it goes down, it costs us $1 million a shift. That pump impeller absolutely needs to stay on the shelf in stores. We need to be able to rebuild that pump immediately. But if we have 6 or 8 or 10 pumps in a row on another operating unit that's not as high value, then it does not make sense to have 4 pump impellers on the shelf and be paying inventory tax on these. Our Singapore site actually did a study on impellers by themselves several years ago, and they found out that 40% of those impellers were never put in service or never would be.
Wow.
Because either the engineer re-rated the pump to take a different style impeller, or he replaced the pump to take a whole different brand impeller, or for whatever reason, that impeller never made it to the field and went to the dumpster. So that value capture along with inventory tax is substantial. So when we talk about scaling additive, our digital supply network is going to scale additive for us faster than anything. So as these machinery specialists are having to remove these items from stores and create digital models instead, they'll be relying on us heavily to identify which parts they need to be scanned. Once they're scanned and once they're in Field Node, which we're a member of, that's how we'll easily be able to print parts instead of going through the entire workflow of taking this part from scanning all the way to printing. That part will already be in Field Node ready. You just hit one button to send for request for quote.
Okay, so you're building up a digital inventory
Yes.
of low demand or lower impact applications, right?
Not just low, high also. So that $1 million a shift pump impeller will absolutely be scanned, and when it's replaced, it may be printed instead of casted when it's replaced.
Okay. So you guys then also have that reverse engineering capability within your teams.
Yes.
Where you go from scan to, I'm sure there's still some manipulation in CAD.
Yep.
And then you store that in a digital inventory available to everyone at Exxon.
Correct. And it's even almost all of the oil and gas majors are a member of Field Node, with the exception of Chevron. There are several companies, and all of these files are shareable as long as they're not IP only parts, right? So there's a section of parts in Field Node that's for IP only. Only the consumer can see the file, because obviously we compete against each other with advantaged parts. But there's a larger section of parts in Field Node where, for example, Shell can say, hey, I need this pump volute scanned. Hey, wait a minute, let me go into Field Node and see if Exxon or ConocoPhillips or someone else has scanned the same pump volute, and then I remove a step from my workflow. So if they go in there and it's ready to print, then all they have to do is hit that button to send for request for quote.
Interesting. Can you explain what Field Nodes is? I'm not sure everybody knows what that is.
So Field Made is a European company. A spinoff of Field Made is Field Node. They created it as an industry collaboration project between oil and gas majors, with the sole intent to create a digital supply network and to have companies work together instead of slowing. So what we were all doing as oil and gas majors is slowing the adoption of AM and scaling of it, because we were having NDAs on pump impellers and things that really didn't matter, right? And why do that? We felt like it was just top secret. We didn't want to know what each other was printing. So now fast forward with Field Node, we're all working together to scale additive, and it's really been great and needed. Much so probably like aerospace did. There's some sharing of information to scale additive faster, not just all IP.
So it's becoming less of a competitive advantage to hold information and keep it tied to your chest versus sharing it, and therefore also getting access from your quote unquote competitors to some of their files for the greater good of adoption, and therefore achieve economy of scale to over time reduce the cost of additive, have I'm guessing also the objective of having a larger contract manufacturer network out there that
Yes.
you will rely on, push standards forward, etc.
Yeah, and I think you see that too with Siemens. So companies like Siemens. So Siemens was kind of tight-lipped about what they were printing, and if you asked them, they would maybe tell you some. But we saw at the A-Mode conference this spring, they really presented a session that pretty much told us everything they were doing, and it's already improved. So there's some things that we were doing that were pretty close in parallel to what they do, and we learned from that, and they'll learn from things we do. So yeah, it drives adoption of AM and scalability. And as you referred to, there's going to be more print shops because of that, and that lowers the price. The more shops there are, the lower the price, right? So
Yeah.
all
The
good.
better your lead times, the more accessible it becomes, and so on. So now you mentioned that Exxon turned their headquartered corporate initiative now over to the sites, which also means that there's a certain level of maturity now for additive, right?
Yes.
What does that mean exactly? Do the sites have capital equipment and print on sites? Do they have technical expertise in order to outsource? What does that localization really mean to Exxon additive?
Well, it means in North America, we use, let's just use an example. So laser powder bed fusion. We have a network of providers inside Field Node. So the other great tool that Field Node is they get up as board members, and there's a board member from each oil and gas major. They get up together and they go qualify vendor shops against API 20S, right? Because in the rest of the industry, you've had 9001 ISO for a long time, right? So we've not been able to do what the rest of the industry could do, but now we can. So these vendor shops, most of them aren't familiar with 20S. So we identify them at conferences, trade shows, anywhere we meet. And once we identify a vendor we would like to be part of Field Node, because we know what machines they own more than anything and what they can do for us, then that board gets up and goes and qualifies them and audits them against API 20S. If they pass the audit, they're invited to join Field Node free of charge. And there's no reason not to do that, right? Because every member of Field Node is oil and gas major, and they're going to send you requests for quotes. So really good for both of us. But yeah, that's the main benefit.
Interesting. Yeah, it seems like really one of the first true distributed manufacturing platforms in use. How many parts are on that platform? And do you know how many parts Exxon sources in a week, a month, whatever the time frame is?
It'd be really hard to tell. I'm kind of keeping track of our North American folks a pretty good bit. So we're probably at a point of maybe 10 parts a quarter in North America. I'd say Singapore's much farther ahead. They're looking at, I can't give you an exact figure, but they're looking in the millions of dollars of printed parts this upcoming year. One thing to know is whatever any of our sites is doing anywhere across the globe, the other sites are going to be doing that in years to come or months to come, depending on how long it takes. So the good thing is everything that that Singapore does for us, we're able to capture those values, and we're able to copy that a lot easier than if we had to start from scratch, right?
Gotcha. So as soon as one side qualifies additive for a certain application, has it reverse engineered, it becomes an approved internal part, and therefore can then be replicated all across the board. Is that how it works?
And yes. So companies like Voestalpine, they're a global company. They have vendor print shops, relatively close to a lot of our sites. So in North America, probably Knuth Godwin and Voestalpine and Halco in the laser powder bed fusion world. Those are kind of our go-tos. They're all members of Field Note, and you have a mixed bag across the globe. But Voestalpine is kind of emerging as that company that is showing up in a lot of places. So they've been a really good source for us for laser powder bed fusion parts.
Interesting. Let's talk a bit about different types of applications. So you mentioned impellers. What type of impellers, but also what other types of applications do you see the biggest demand for additive in today?
Today, laser powder bed fusion is top technology. I think you're going to see WAM and wire and powder DED emerge as fastest growing. Laser powder bed fusion is mature. I mean, what we're seeing now is just faster printers when they're made, bigger volume. We're already past being dense enough. You're 100% dense
now
already.
You're going for speed.
Yeah, now you're going for speed, and speed means less time on the machine, means a cheaper part. We look at those Nikon NXGs and the Velo Sapphire XCs, the large machines that EOS is partnering with. We look at those machines as a savings too, because when we originally saw these machines, we thought, okay, everybody's just building parts that large, and that's the goal. But as we're seeing, that's half of the goal. The other half of the goal is to have 10 small parts on that build plate, and you cost share with other customers. So that's going to drive costs down also on parts.
Yeah. Sure.
And then like the Nikon machine has 12 lasers, and it prints 5 or 6 times faster than its younger brother. So you're just going to see a lot more of that, and you're going to see faster machines in bigger volumes, and we're going to see cost savings. But in the wire DED and the WAM world, I mean, we have lots of parallels with maritime DOD, because we both have these legacy cast iron pump and other parts, right, that need to be replaced. And WAM is just a really good option for replacing cast with something you may not have to replace for 5 times as long, and your lead time is much shorter, and in a lot of cases cheaper. So some of our big castings that are 4 or 5 feet tall and 3 feet wide, like a Y for a large pump, or we recently printed a pump discharge casing that was probably 3 feet cubed. These lead times are 4 to 5 weeks versus 12 months or 14 months, and cheaper than casting. So that's why you're really going to see that technology emerge, is replacing legacy cast iron pumps. So this refinery was built in 1903. The office I'm sitting in right now, and we talked about if I should go to a nice conference room or stay in this office, and you said, I think let's look at the vintage aspect here. But this office, there's a brick outside my door that's got 1948 stamped in it. So old legacy parts. I have a compressor that was built in 1938.
Wow.
We're absolutely going to print some parts for it. There's a lid that goes on the crankcase that is odd shaped and is perfect for WAM and not perfect for any other way to make it. So lots of legacy cast iron parts. And then you alluded to what capabilities we have at our site. So here I have probably 20 FDM plastic printers that we prototype with, and I have 3 Form Labs resin printers, and we have a new Meltio M600 wire DED machine. So we're getting started very soon. We just received it a month ago. We've printed probably 20 items, none to put in service yet, but tomorrow we'll print our first part in Inconel 718 on it. And we have plans to add its big brother, the robot cell, maybe next year. And we have a wire EDM machine on the way. So we don't necessarily look to do that at every site, but the more I do that here, myself being one of the leaders in additive for the company, the more I'm going to learn about the process. So
yeah. Is your objective also to pre-qualify certain applications in your facility and then push them out to suppliers for production?
yes.
Or are you actually also looking to use your facility as a production house?
Yeah, so we are in Field Node as a service provider. So
Okay.
probably not Shell or ConocoPhillips, but if we had another Exxon site that wants a part made, they can use us to make anything that we're capable to make. So I haven't added the Meltio machine to it yet because we're still beta testing and getting it dialed in. But as soon as we're finished with that, I will add it to Field Node, and our other sites will be able to order parts from me from our site.
Interesting.
Yeah.
And then so we talked about impellers. It's an obvious case for additive, especially also laser powder bed fusion. You talked about a certain casting replacements and like pump housing type parts. What other types of parts do you see additive really lending itself towards?
So I mentioned that maritime DoD, we have some parallels.
Yeah.
We also have some parallels with aerospace. So we have pyrolysis furnace parts that we have printed already, and we probably only going to increase in the parts that we've already printed and others. So we're evaluating some now. We created a proprietary powder for laser powder bed with Sandvik 2 or 3 years ago. So those parts are in service at another facility. It turned out to be a really good project for us. So, yeah, partnerships with other companies to make specific powders have been advantageous to us for sure.
Okay. Are all those parts behind you 3D printed?
Yes, they are.
Okay. Can you take us through their function, what they are from?
Yeah. So this is a tower tray bubble cap. It is binder jet printed.
Okay.
And this part was formerly a stamped steel part, and it was 9 parts tack welded together to make this part here that is printed in 2 pieces. So kind of what happens is we get into a turnaround window here at site, and our turnaround window is usually 6 to 8 weeks at the most. So if we go into a tower and we find a tray that has 200 bubble caps on it, and we did not expect to find any damage on a specific level of that tower, and then we go and inspect once we enter the vessel and we see 20 bubble caps that need to be replaced. So what happened in COVID is a lot of these stamped steel companies went out of business. So the die to make these is gone now if that company went out of business. So we've got to do something quickly, and we've got to receive these parts in, 6 weeks or 30 days to be able to get this unit back up and running on schedule. So we just evaluated binder jetting as a method to maybe make some of these short notice for turnaround.
What does a bubble cap do?
So vapor comes up from a tower tray, and it forces it to turn down, and it forces vapor into the liquid. So whatever that chemical may be that's in the tower tray, it forces the vapor into the liquid.
Okay. To achieve a certain chemical reaction.
Correct.
Okay. Gotcha.
This part is a machinery anti-wicking device. So radial thermocouple wires on bearings on large compressors and gearboxes, they wick oil up the instrumentation wires, and you can't stop it. So if your next place for those wires to go is a stainless steel cabinet, that's still bad, because what you end up having is some oil soak pads and a mess, environmental mess out there, and then maybe some performance problems. If you have an HMI cabinet between, the bearings and in the cabinet, you're really going to have a problem because that's where your electronics are. So this device is made to keep the oil in the bottom of this pot. An O-ring goes in this groove, and this plate has terminal blocks bolted on both sides, and it pops it in so that the oil can't get above this plate. So essentially you have instrumentation wires coming in here from the bearing, and then you tie into the top terminal plugs and continue to your cabinet without oil.
Interesting.
So this is a Ultim 9085 part printed in a Robos 500, Argo 500. So this won this is a LSU capstone project, and it won the Ben Burns Award for Best Project 2 years ago.
Oh, cool.
This is last year's anti-wicking device, which we chose to print in 316. So Halco printed this for us on their SLM 280 at their shop. So it is a little more impressive because of just what you can do.
Yeah.
With
awesome.
laser powder bed. You can't do that with Ultim. And it's a little more robust, so it's heavy. And here you see those terminal blocks that you would see on the other part.
Okay, cool.
Same design as far as keeping the oil in the bottom with the O-ring. Look, our instrument folks like this part a little better. It also won first place, and it won the Ben Burns Award for this project.
Interesting.
In May. This is a commodity item. So everybody says additive always costs more. Well, not every time, because this is a machined part that we pay $540 for.
Okay.
The reason why it's $540 is because those are 4 threaded parts threaded together to make a whole part and tack welded together. We get this one for $196 each because it is all in one piece.
Cool. Yeah, and quite complex as well.
Yep. So in bulk, I get these for $196 because, I can fill their whole print bed up with these. If I order that amount, they can do it that cheap. So that's a good reason to add something to store stock instead of remove it, because there's savings. The rest of these parts are printed on our M600 in the last maybe 3 weeks. So these are all prints that they have in their cloud storage, except for, just for fun, we'll call this a bourbon glass. Certainly not what it is, right?
Just for fun. Exactly. Just for fun.
Yeah. The machine really puts out some high quality parts. Really impressed with it.
Yeah, that's awesome. Super cool. Okay.
And then in the plastics world, this is a gas test to skin up from toting it all around show and tell. But it's a gas test bottle for testing gas vapor. So that's printed on a Formlabs 4. And then I can't help myself. Every now and then we print something almost useless, but fun. We had to do that to begin with. We're on to real parts, no more fun.
Well, you gotta sprinkle in a little fun here and there.
Yeah.
To keep it going. Okay, cool. No, thank you for showing those parts. It's really impressive how broad of a technology adoption you guys are going for, right? Yeah. Which I think is really supportive of the fact that there is a place for every additive technology, at least for most, I think. And you guys are really showcasing that sentiment. You also showcased that workforce development, partnerships play a very big role in adopting and pushing additive. Can you tell us a bit more about your center of excellence in Baton Rouge, but then also how you guys are collaborating with universities and education institutes like LSU?
Yeah, so we're a member of a company called LAMA. That's Louisiana Additive Manufacturing Association. So as a member, we have a seat on their board once it's formed. It's young, but the idea is they would like a center of excellence here in this area, and we would like there to be one, right? Because they have a membership structure that's set up in a way that's very attractive for us for scaling additive, and it's a 3-in-1 tool for us. So we get to scale additive inside it, number one, because it's going to have every printer that we utilize to make our parts in the building. And number two, it's a way to train our site personnel and engineers here. So in retrospect, we have maybe 10 engineers in our main office, mechanical engineers, and maybe one of them has a little experience with additive. The rest, came here before additive was really kicked off, and they don't know much about it. So it's a way for them to learn, because it'll be fairly close to here. And then the third reason is obvious, like workforce development. So DOD's America Makes is involved with us. There's talk of them making it their next satellite center, if it happens, and really for workforce development. So DOD needs somewhere to train in the region. There's nothing remotely close to here. University students need somewhere to train. There's nothing remotely close to here that has all these machines available anyway. So Baker Hughes was very generous. They offered their curriculum that they've been teaching their engineers internally for 10 years with, it's exclusive to Llama. So there's 2 universities close to here that are talking about making an advanced manufacturing elective to go along with their mechanical engineering degrees, and that would be a component of it possibly. So what it would look like is, a classroom section and then a lab in the back, and then students could go back there. And the bigger idea is, if you have 5 laser powder bed fusions back there, they don't need to be the same brand. They each need to be one of the major brands, and these students can go and certify on each of those machines. So that gives them a path to go work for a EOS or a Nikon SLM or a Velo or whoever. And it also gives them a path to go work for a service provider that owns those machines. So just giving them another way to be employed in the region, other than just to come work for ExxonMobil or Shell or some of the other petrochemical companies, which is kind of the main source of employment for them here. Manufacturing is not for everyone, not in the oil and gas or petrochemical space, but some of these students we hope will really latch on to additive and find that more interesting.
Yeah, I hope additive can make manufacturing a bit more. That's always been cool, but make it give it that innovative and new taste that attracts talent into the industry.
Yep. Back to the part where I said the membership fee was attractive. So they have several different levels of membership fees, and you can change your level of membership as they get new machines and as they get more capable, in case they don't buy all these machines at once, right? Because it would take a nice grant to be able to buy them all at once. So in the event they don't get a grant like that, they would scale up slowly, and we could scale up our membership with that. But for example, if we joined at the highest level membership, it would afford us 5,000 free print hours on machines in the COE. So that's extremely attractive. So as a business, if you can pay a fee and make double that in parts, that's a pretty good deal, right? So
not a bad deal at all.
That's the allure. And the only thing you pay for is powder during those 5,000 print hours. So
okay.
A $16,000 pump impeller becomes a $600 pump impeller potentially, or a $1,600 pump impeller during those 5,000 hours. So that is a great way to scale additive manufacturing.
Yeah, and to your point earlier, also the increasing the utilization of that equipment to the max will also therefore help everyone, I'm guessing. Now, when it comes to Exxon, what type of talent are you guys looking for in the additive sector, at least? Are you looking for engineers that can support on the reverse engineering and feeding parts into your platform? Are you looking for technicians, or is that more a demand on your supply sides? How do you see the makeup of that workforce demand?
So engineering is different. Obviously, their production and our units come first. So if we ever have experience in engineering, at least for the unforeseeable future, it's just going to be engineers that got experience by going through something like the COE or coming from a college that has a lot of additive and they participated in it. We don't really right now hire engineers for additive at sites. Hope that changes in the coming years, but nothing on the horizon really. As for technicians that print, that's non-existent and may continue to be that way because we're a union site. So there is no union craft for 3D printer technicians. So we have instrument techs and electricians and machinists, but outside of that, there is no union for 3D printer technicians. So what we end up with is some machinists that we hired that have a robotics and AutoCAD background from either their college days or they were an experienced hire from a machine shop where they did it, and kind of morphing those employees into the people that run the machines. Obviously, I have none of those qualifications, and I'm doing it myself, so it's not rocket science, at least until we get a robotic machine. Then I'll probably not be able to run it myself. I'll be relying on those guys. But that's what workforce development for additive looks like right now. There's just not any
Mhm. Yeah, and
internally.
I think we need a more diversified backgrounds in additive too, right? If I look at a lot of teams, you see material scientists, you see quality engineers, you see design engineers, technicians, people with a machining background. It's all across the board, which is actually, I think, a very good and beneficial thing for companies to have that broad viewpoint on manufacturing and not just the additive view itself.
And we have a lot more than some other sites do, right? So what we also have in Field Node is we're going to have engineering firms that are members of Field Node as vendors. So if you have a scan or just a 2D drawing or whatever of a part you need made, you can actually upload that part into Field Node, and then you can send requests for quote for an engineering service to make that a 3D printable model for you, and then you can send it on to a vendor. So that's how the sites that don't have much of any capability can do that.
Mm-hmm. Interesting. Let's talk a little bit about the future a bit. On the one hand, I'm very curious on the remaining challenges that you see to really deploy additive at scale, right? I mean, you mentioned earlier at the moment you guys are printing 10 parts per quarter. I'm sure there's demand for thousands of parts per quarter if additive is at scale. What needs to still happen to get to that point?
Well, our biggest bottleneck right now is the workflow from scanning a part all the way to sending it to a print shop and answering those questions that the print shop needs, because they're going to ask you, what material, obviously, but they're going to get all the way down to what RMS finish do you want on this part? What, all these questions that sites are going to be like, well, I don't know. Let me call our corporate materials engineer and ask him what they've been doing. Right. So it has to be better than that. So the good news is we're members of the International Association of Oil and Gas Producers, so IOGP. I just joined as Exxon's spokesperson maybe 2 weeks ago. They all met last week in Venice, Italy, face to face, but I wasn't able to go. Angeline Go with Shell is, I think, the chair of this project. So I think IOGP funded a joint industry sprint, so JIS02, and the intent is to help streamline this process, right, from part to printed part. So it's obvious when you look at API 20S, and then if you go look at ASME standard or ANSI standard, none of them talk well to each other, and there seems to be something missing a little bit from each one if you're looking for just additive. But I think the task is to make all these talk together and to create a digital passport, which they've done great with. I reviewed it. last week. It looks great. So what it looks like is if I scan a part and I just have raw scan data, I can put it in our system. Well, let's talk about Exxon generally first. So our system is to scan a raw scan data, and we call that a DRL1 part. And this JISO2, this digital passport, is very similar. And I think our additive lead, John Barnes, that used to be with us, he kind of modeled it after what they were working on because he was working with it closely. So that's all the scan data and a PMI reading of the material, and then maybe a Brunel hardness test. Those are the things we need to print a part later. So we can actually, if we have that data, we can store it in Field Node, and we know we have everything we need to print a part. But what we don't have is everything the vendor needs to know to print the part. So you go from DRL1 to DRL2 and to DRL3. So digital readiness level 3 is everything they need at the vendor shop to print the part. So there's an inspection and test plan in there. There's, lines out what they need already for roughness, or what they need for testing, what they need for post-processing. Everything is just in there ready to print. It's ready to, you hit that button and that's all you have to worry about except for waiting for a quote and lead time.
Okay. So really, the streamlining the process and also really knowledge management seem to be then a key enabler of rapid deployment.
Exactly. I was on a meeting yesterday morning with some folks from Saudi Arabia at one of our sites, and I'd never spoken to them before, and I don't think they had ever spoken to anyone in additive yet, but they wanted to print a part with a local vendor, and they didn't really know about what API 20S said. They didn't know really what they should look for in a vendor as far as what to audit them against, or what a red flag looks like if you visit, and we start getting into, virgin powder and recycling powder and how are you recycling powder and those type questions. So we deferred them to our materials engineer that deals the most with additive at our corporate level, and they learned a lot during that meeting. But more than anything, they know that when they print with this vendor, they're taking a risk, right? Because they're not 20S qualified or have been audited against 20S, and they're choosing on their own to just try it out, which we don't really condone. But they're in a situation in a country where the country really doesn't allow you to outsource from another country. They want you to do it inside the state. So
interesting.
There's that.
When it comes to success, so if you look into the future, and Exxon has deployed additive successfully, or let's say even the oil and gas industry has deployed additive successfully, what does that mean? Does that mean we have dozens and hundreds of qualified contract manufacturer? Is there a certain number that you think if that's printed a month and you hit a certain critical demand, what does that look like?
Yeah, I think you track how many parts are printed per quarter, and I think those parts are in the 20s, 30s per quarter. I think that's probably playing it safe to say that that's probably the number where we would live at this site. Once everybody's familiar with it and it's normalized. But yeah, lots of shops, and not having to explain to them that there's a standard for oil and gas called API 20S, and look at that one instead of just ISO 9001. Once everybody knows what it is and is familiar with it, and the IOGP JISO2 is they've achieved everything that they're looking to achieve there, I think everything's going to be normalized, just as normal as getting a casting made. And really right now it's sort of sad to see people question a laser powder bed fusion part when a casting is supremely superior, inferior. But it's just crazy. Like if we jumped in a time machine and went back 100 years and somebody gave us the option of a mature laser powder bed fusion part and a casting part, nobody would choose the casting. We would never have used it before. But now we just cling to it because that's what people are comfortable with.
That's what
and
they
they're
know.
just holding on to the past. But laser powder bed is the future.
So you think 30 parts per quarter of printed parts, that already means success per site?
Per site, yeah.
How many sites are there?
That's a good question. I've never counted them all, but there's
like 5, 10, 100.
Oh no, there's lots in North America. There's lots all over the globe. That is a question I'm not prepared to answer, but I would assume there's closer to 100.
Okay.
Globally.
Well, okay. That's a pretty good amount of parts. So the demand is there. We just need to fix the supply in the end. And those two other problems. Okay.
And you talked about production parts earlier. It's going to be very rare that we do anything in production. Everything's going to be a ad hoc part needed at the time of need.
Yeah.
It's going to be rare that we print anything in production and print more than maybe 3 parts at the most of anything. Except
for those consumables that you showed up there.
Yeah. It's a very rare situation.
Okay. Interesting. All right, one more question for you. You guys have the first ever additive manufacturing oil and gas summit coming up. What should people expect?
So every conference that I go to, every expo, every event, I always they always have an app these days, right, for every event. I always look as soon as I get there or on the plane flight to it, who's there from oil and gas that I can talk to. And the answer is always none, 1 or 2. And you end up chasing these people all around the conference so you can get to talk to them. Well, they're all going to be in one room this time. So that's going to be much needed. Really glad that they decided to go after oil and gas as the next conference. I think it's going to be a huge success. I think it's going to help drive and scale additive as a result.
When is it and where?
It is on October the 15th and 16th in Houston, Texas.
Okay, there you go. Mark your calendars if you are or want to get into oil and gas, or you want to meet Chris in person. Chris, it was awesome to have you on the show. It was awesome to finally get a deeper glimpse into the oil and gas industry and how additive is shaping your sector. And thanks for the transparency. I think it was awesome to really, really talk in depth. And it seems like oil and gas has really figured out how to collaborate. So super awesome role model, I think, also for some other sectors where keeping information close to your chest is still more the standard. So thanks again for being on the show.
Thank you, Fabian.
And thank you out there for listening to today's episode. If you enjoyed it, please share it with your friends, colleagues, or anyone who wants to learn about oil and gas and additive. Also, if you have any questions for Chris or myself on this episode, feel free to leave a comment or shoot us a message directly on your preferred social media platform. This was the Additive Snack podcast, and I will see you next time.